A vector can be drawn as an arrow which shows direction and a magnitude A. The start is known as the initial point and the end is known as the terminal point. As we see on this diagram, A is the initial point and B is the terminal point. The direction of a vector can be written as an angle between the vector and the positive x-axis, or as a bearing shown in these two diagrams. A bearing is anti-clockwise from north, so we could write the bearing as 0, 3, 0, as shown in the picture on the right. If we have more than one vector, we can create something called a resultant vector. A resultant vector can be drawn in the following way, using these steps. Step 1, we draw the vector B so that the tail of B is at the tip of A, shown in step 1 here. The resultant is the vector from the tail of A to the tip of B, shown here as the green arrow A plus B. Here is an example for you to try. What is A plus B? You may pause the video now, answer the question, and then see the answer after. You should have got that C equals 6 and shown the orange arrow. Here is a real-world example involving an aeroplane flying at speed with wind coming in one direction. You see the blue line is the aeroplane's speed and the red line is the wind. We now have two vectors and we can create a resultant vector which is the green vector G, as shown in figure 7.1.5. We can now use the law of cosine to find what the speed G equals. Here is the formula for cosine. If we plug the numbers in and follow it through, we get that G is approximately 299.4. So the ground speed of the plane is about 299.4 knots. We now know the ground speed of the plane, but the resultant angle we can find using the law of sines. Here is the law of sines formula, and if we plug the numbers in again and follow it through and take the inverse sine, we get the answer of 14.6 degrees. So the measure of theta is 50 minus alpha, which is 50 minus 14.6, or 35.4 degrees. So the final answer is that the plane is flying at 299.4 knots at about 0.35 degrees if we are going to write it as a bearing. Okay, here are 3 questions for you to try. Now, using what I have taught you in the previous slides, I'll give you some time to answer the questions and the answers will be revealed on the following slide. You can pause the video now, try the questions, and the answers will be on the next slide. Here are the answers to the 3 questions. Question 1 and 2 just wanted you to show us the resultant vector. Question 3 wanted us to find the speed and the direction. As you can see here, we can find the speed by using Pythagoras, which would be the yellow arrow, and it would equal 4.03 feet per second. To find the angle, we can use the sine rule, and you should get 0.125 to the north, or 35 degrees below the positive x-axis.
Now, before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below, and send us a message now. Okay, with that said, let's get back to our lesson.
The component form of a vector AB with initial point A and terminal point B is given by the following formula. As you can see from this diagram, we can calculate the red dotted line by minusing the x values, and we can calculate the light blue line by minusing the y values. Here is an example. It says find the component form of AB, which has initial point -4, 2 and terminal point 3, -5. We can find AB by minusing the x values first, so 3 minus -4, and then minusing the y values, -5, -2. We get 7 minus 7 would be this vector in component form. We can also work out the magnitude of a vector by using Pythagoras. We see here the formula is a version of Pythagoras. It is V equals the square root of the difference of the x value squared plus the difference of the y value squared. So an example here would be find the magnitude of the initial point -4, 2 and the terminal point 3, -5. The magnitude of AB would be the square root of the difference of the x squared, so again 3 minus -4 squared, plus the difference of the y squared, so -5 -2 squared. We get that the answer equals the square root of 98, or around 9.9. We can also do operations with vectors. For example, if A equals A1, A2, and B equals B1, B2, we can add them, we can subtract them, and we can multiply them by a scalar. If we are doing addition, then we add the x components and the y. If we're doing subtraction, we subtract the x components and the y. And if we're multiplying by a scalar, then we just multiply by whatever number that may be. An example here is shown. W equals -4, 1, y equals 2, 5, and z equals -3, 0. We want to know the resultant z minus 2y. If we follow it through with the addition, subtraction, and multiplying by a scalar, we get the answer -7 minus 10. Okay, so now we have unit vectors. A vector that has a magnitude of 1 is called a unit vector. To find the unit vector with the same direction as another given vector, we can use the following formula: U equals V over the magnitude of V. We can find the direction and the magnitude of a vector using the following. The x component is the magnitude of V cos theta, and the y component is the magnitude of V sine theta, as shown in this diagram on the right. If a given vector is in the form V equals I plus j, we can find the direction using the tan function as shown in these steps. We would do tan theta equals 7 over 3, and then take the inverse and get theta equals 66.8. Here are 6 questions for you to try. Now that I have taught you many things on vectors, I'll give you time to pause the video, try the questions, and the answers will be revealed for you on the next slide. Here are the answers to the 6 questions. I would like you to check your answers. Hopefully you got them all correct. If not, then please do look through this PowerPoint again and try to redo the questions. That is all for this PowerPoint. I hope that you are now more familiar with vectors resultant vectors, unit vectors, finding the magnitude of a vector, and other things like this. I hope you enjoyed this PowerPoint, and yes, I wish you all the best in the future. Thank you.